Right. Today we supposed to start the practice paper 2. Yeah. Its first question is we are given fx function. Number 1, fx function given 1 over square root of x plus 2 for x greater than minus 2, and gx function given 2x plus 1. Right. This we given fx function and gx function. Asking to find the domain of the function f upon g. F upon g function we can write f over g x, no, right? It is really fx upon gx. Fx function is 1 over root x plus 2, substitute here. Gx function is 2x plus 1. Then this is what we get. Square root of x plus 2, gx function is 2x plus 1. Right. Then here f over gx is this. Now you know here this must be positive, or actually this must be positive, and it can't be 0, because if this is 0, again this has no meaning, and this should not be equal to 0. Therefore this should be positive, this should not be equal to 0. Right. Then here x plus 2 should be people greater than 0, and 2x plus 1 should not be equal to 0. Right. Then here x plus 2 greater than 0 means x greater than minus 2. And here x should not be equal to minus half. Right. Then we need to take the common region for this and this. Right. So the common region you can mark really this way. X greater than minus 2, here minus 2, circle this up to infinity, right? But here x should not be equal to minus half. Then here minus half, right? It doesn't take. So then the this domain of this function going to be, right, this interval, right? What is that? Minus 2, this, right, and x greater than minus half. So we can write the domain this way. Domain, then we can write excluding minus 2, excluding minus half, union minus half excluding up to plus infinity. This is the the domain. Is the domain. Right. First part is that. Secondly, asking obtain the value of f over g2. F over g2, you can write this as f2 divided by g2. f2 mean we have substitute for this x 2, 1 over square root of 2 plus 2. g2 means put here 2 and 2, 4 plus 1 is 5, no? This way. Then we get here square root of 4 is 2, here 5. Then there we get 1 upon 10. Right? 1 upon 10 coming there as the answer. Next one asking to take this FOG 11. Right. FOG 11. Composite function G and F. No? Third part. FOG 11. This is really FG11. Right? FG11 put here 11. There we get right 2 into 11 plus 1. Then 23. F23 put to find F23 here x23. 1 over square root x is 23 now plus 2. This is 25. Root 25 is 5, 1 over 5. So this is the FOG 11 that we got. Right. Here's a question number 1. Right. Question number 2. A. Given simple a comma 2, B given 3 comma 4, and AB length given as 8 units. Find the value of A. Right, AB 8 means AB squared equals 64. Squaring both sides. Squaring both sides. AB squared we can write difference of x coordinates perfect squared plus difference of y coordinates perfect squared equals 64. Here we get a squared minus 6a plus 9. Here we get minus 2 squared is plus 4 minus 64 equals 0. This we get. Then here furthermore when we simplify this, here we get minus 51 equals 0. Now we get a quadratic equation in A. We'll find two answers for this A. Right? We can use that quadratic formula. What is the quadratic formula? A equals minus B. B is minus 6. Plus or minus square root B squared minus 6 perfect squared. B squared minus 4. A is 1. C is minus 51 divided by 2 into 1 is 2. And then when you simplify this, we get here 204, here 6 square 36, 230. Right, then we can simplify it like this. A equals 6 plus or minus, I'll write it like this, 6 squared is 36 and here plus 4 into 51. This way I write it, divide by 2. A equals 6 plus, shall we take this 4 out? When I take 4 out from this, we get 2 there. Then this third 6 we can write as 4 into 9. No? 4 we took out. Here 9 plus here 51 divided by 2. This 2 we can cancel down like this. A equals 3 plus or minus. Here we get 60. 60 means root 60. It means 4 into 15. Then 2 root 15 come in there. No? 2 root 15. Then A has two values. By plus sign 1. By minus sign the other one. This way. The other two values for A. Next one given. Second part. P, Q, R be 3 verses of a square PQR is, right. P, Q, R, S. Right. P is given as 1 0, Q 6 1, R 5 6. 1 0, Q 6 1, R 5 6. Right. I'll take S as X bar Y bar. This square, no? Then the diagonals bisect each other at right angles this way. Here 90, these two are equal, these two are equal, all 4 parts are equal. Huh? But it's asking there. Find the coordinates of the point S. Yes, this, right. Now, this is the midpoint of QS diagonal. Same point is the midpoint of PR diagonal. In coordinate geometry, we know how to write the midpoint coordinates. Adding x coordinate, dividing by 2, we get the x coordinate of the midpoint. Adding y coordinates of the 2 points and dividing by 2, we get the y coordinate. So then this point x coordinate we can write in 2 ways. X bar plus 6 divided by 2. Same x coordinate you can write 1 plus y divided by 2. Right? Then if I take this point as t, right? X at t, we can write how, people? X bar plus 6 by 2 equals 1 plus 5 by 2. This and this we can cancel down. Then we get x bar 0. Y at t, same way we can write y bar plus 1 divided by 2, 0 plus 6 divided by 2. Then we get y bar 5. Therefore, S 0, 5. Right? Point S is this. Its third part. In the triangle ABC, A, B given, right? A here, B here, A minus 2, 1, B 2, 4, C x bar y bar. Right. Right. Suppose this is G, the centroid. We are given If the coordinates of the centroid of the triangle ABC is 1, 2, centroid mean this is the midpoint of AB. This midpoint of AB we join to what vertex C. Then this line is called as the median. In the median, this G divides the median in the ratio 2:1. Right? Such point only we define as the centroid. Okay? Right. So we are given the centroid has the coordinates 1, 2. Then asking to find what people? The coordinates of C, x bar, y bar. Right. You know, the x coordinate of the centroid is given by sum of the x coordinates of the 3 vertices divided by 3. That means adding the 3 x coordinates of the 3 vertices and dividing by 3, we get the x coordinate of the centroid. Right? That we proved in the class. Right? We know. So, we can write therefore x bar, x coordinate here, plus minus 2 plus 2 divided by 3 should be equal to here 1. Then this 2 we can cancel down. Then we get x bar as 3. Right? Similar we can write y bar. How? Y bar plus 1 plus 4 by 3 should be equal to 2. Then we get 6 there. Here we have 5. 6 minus 5 is 1. Then we get the point C. Therefore, point C going to be 3, 1. This is how we take those answers. Right. Right. Next question. Right. Okay. Question number 3, part 1. Prove the following identities. Right. Cosec theta divided by cosec theta minus 1, cosec theta divided by cosec theta plus 1. Ask and show this is equal to 2 sec squared theta. Right. You know this cosec theta is 1 over sin theta. No? 1 over sin theta. Here 1 over sin theta minus 1. Here 1 over sin theta. 1 over sin theta plus 1. Right. I wrote cosec theta as 1 over sin theta. Now what I do is this numerator, denominator, both we multiply by sin theta. This numerator, this denominator, both we multiply by sin theta. You know, when we multiply both numerator and denominator by the same value, the fraction won't change. Once we multiply this by sin theta, that sin theta and this sin theta will cancel and give in 1 there. Here, this sin theta and multiply will cancel, give in 1 and minus sin theta. Same thing we do here. Numerator, denominator, both we multiply by sin theta 1. Here, 1 plus sin theta. Now, we can take the product of these two as the right common denominator. This comes here and then this comes here when I write the numerators. Okay, these two you can cancel down. We get 2. 1 minus sin theta, 1 plus sin theta means 1 minus sin square theta. Why? Here we have a minus b into a plus b, factors of difference of 2 squares. Then you can write it as 1 squared minus sin square theta. That means this. But you know 1 minus sin square theta is cos square theta, right? 2 over cos square theta. 2 over cos square theta mean, people, 2 times 1 over cos square theta. 1 over cos square theta means sec square theta. 2 sec square theta, right? 2 sec square theta. That's the first answer. Number 2. Number 2. Sin alpha minus theta plus 2 sin alpha sin alpha plus theta plus 2 sin alpha sin alpha plus theta divided by sin beta minus theta 2 sin beta sin beta plus theta. Right. We have this. Asking to show this is equal to sin alpha upon sin beta. Right. I take this 2 sin alpha to the beginning of the numerator. Then I have this sin alpha minus theta plus sin alpha plus theta. And here 2 sin beta I take before this way, sin beta minus theta, sin beta plus theta. Right, now you can apply CD formula. You can take this angle as C, this as D, this as C, this as D. You know sin C plus sin D formula, you know. Sin C plus sin D formula is what? 2 sin C plus D by 2 times cos C minus D by 2. Right, we apply that there. Then here we have 2 sin alpha 2 sin, because we add these two angles, then minus theta plus theta will cancel, alpha alpha 2 alpha, that should be divided by 2, then alpha. And cos, take the difference, alpha alpha will cancel, minus theta minus 2 theta, that should be divided by 2, then we get minus theta. Then here we must write this way, cos minus theta. But you know, people, cos minus theta we can write as cos theta without this minus sign. Then I erase that, because cos minus theta is cos theta, right? And people, next one I can take 2 sin beta. Here also 2 sin, at this angles 2 beta divided by 2 is beta, and cos, take this angles difference, beta beta we can cancel now, minus 2 t divided by 2 minus theta means theta, you see. Okay, then we can take this way, 2 you can take out from the denominator, 2 you can take out from the numerator, those 2 we can cancel down like this. Then take sin alpha common to this numerator, and denominator sin beta common. First take sin alpha 1 plus cos theta here 1 plus cos theta. These 2 you can cancel down. Then we get the answer, sin alpha upon sin beta. Okay, no? Right. Sin alpha upon sin beta is the answer. You go to third part in it. Part 3 says to prove cosec theta minus 2 cot 2 theta into cos theta equals to sin theta. Cosec theta cosec theta minus 2 cot 2 theta into cos theta. Right. Its answer. People, now this cosec theta I can write 1 over sin theta. Okay. 2 cot 2 theta I can write as cos 2 theta divided by sin 2 theta. Cot means cos over sin, no? Right. And here cos theta. 1 over sin theta to cos 2 theta I write 1 minus 2 sin square theta. We know for cos 2 theta there are 3 formulae. Cos square theta minus sin square theta. And the other one is 2 cos square theta minus 1. Third is 1 minus 2 sin square theta. Right? Okay. Now, this sin 2 theta we write 2 sin theta into cos theta, and this cos theta also. Here we have this 2 you can cancel down, this and this you can cancel down. Then the sin theta is the common denominator. Here we have 1. By this minus sign, when you remove the bracket, we get minus 1 plus 2 sin square theta. Then this 1 and 1 we can cancel down. Now there we have sin square theta divided by sin theta. 1 sin theta we can cancel down with this sin square theta sin theta. Then we get 2 sin theta as the answer. This is how we take that answer. Right. Okay. Next one, question number 3. Question number 4. Right, question number 4. Px given this way, be a polynomial function of degree 4. Px, it is 3x times x cube plus ax squared plus bx plus c plus 6. Be a polynomial function of degree 4. When px is divided by x minus 1, x minus 2, x minus 3, the remainder in each case is 6. Right. Now you know, according to factor theorem, when px is divided by x minus 1, right, we are given the remainder in each case 6. Right. When x minus 1 is a fact of px, remainder 0. Right. Now, according to remainder theorem, when px is divided by x minus 1, remainder given as 6. It means p1 equals 6. Right. Like that, we can write the 3 relations here. We can write when px is divided by x minus 1, remainder 6, therefore p1 6. When px is divided by x minus 2, p2, no, the remainder, that also given as 6. When px divided by x minus 3, the remainder again 6, that means p3 is 6. Then we can put first x equals 1 in the left and right. Then we get P1 here. For that P1 we get put 6. Like that, in the left and right we put x equals 2. Left and right we put x equals 3. Thereby we can draw 3 equations. Okay. Involving A, B and C. Right. Thereby we can take these A, B, C values. Let's see how to take them. Right. Now put in x equals 1. P1 is 6. Right. P1 means put here x equals 1. There are 3. Here 1 cube is 1. 1 squared A means A. 1 into B is B plus C. Right. Plus 6. Right. It is the right hand side. When we put x equals 1, we get that is equal to 6. Right. Now you can bring this 6 to this side, people. We get 6 minus 6, 0. Right. Left hand side we have 3. A plus B plus C plus 1 equals 0. This multiplied by this product 0 mean, people, since this is not equal to 0, this should be equal to 0. This gives us what? A plus B plus C plus 1 equals 0. That says A plus B plus C is equal to minus 1, number 1. Right? Equation number 1 we get like that. Secondly, P2. P2 also 6. P2 6 means P2 we can take, put first 2, then 3 into 2, 6. Here 2 to the power 3, 8. 2 squared 4, 4A. And here 2B and C plus 6 equals 6. Again take the 6 right hand side, then you get right hand side 0. Right? Then this into this product should be 0, no? This is not 0, therefore this should be 0. I write that directly. 8, 4A, 2B plus C should be equal to 0. That gives, taking this 8 to right hand side, 4A plus 2B plus C is equal to minus 8, number 2. 4A plus 2B plus C is equal to minus 8, number 2. Then P3 also 6. P3 also 6, right? P3 means 3 into 3, 9. Right here 27. Here 9A and 3B and C plus 6 is equal to 6. As before, we can say this should be 0, no? This gives us, people, 27 plus 9A plus 3B plus C equals 0. 9A, 3B plus C is equal to minus 27, number 3. Right. Now there are 3 equations. By solving these 3, we can find A, B and C. Right? Okay. Now we can take 2 minus 1. 2 minus 1. Right? Here this is 2, over there 1. 4A minus A, 3A. Right? 2B minus B is B. C minus C will be 0. Minus 8 minus minus 1. Then we get minus 7. Right, let us take this as number 4. Next one we take 3 minus 2. 3 minus 2. 9A minus 4A, it's 5A. 3B minus 2B is B. C minus C is 0. Minus 27 plus 8, it's minus 19. Is number 5. Now people, you can take 5 minus 4. 5A minus 3A, 2A. B and B we can cancel down. minus 19 minus 7, then we get minus 12, no? Then A is minus 6. A minus 6, put minus 6 here by 4. Minus 6, when you put here, we get minus 18. Take this right hand side plus 18. 18 minus 7 means 11. B is 11. Both A and B now we have. Now to find C, people, we can substitute number 1 here. By 1 now we can find C. By 1. Now by number 1. A minus 6. B 11. C is equal to minus 1. 11 minus 6 here 5. Then we get C is minus 6. C minus 6. Right? We found ABC. Right. Then next part. ABC. Now we have. Now what is next part? Let Qx be a polynomial function such that Px equals 3 times x cube x plus 2. Show that x minus 1, x minus 2 and x minus 3 are linear factors of Qx. Right. Okay, now we can take it like this. We are given, people, the Px is equal to 3 times x times qx plus 2. That means Px equals 3x into qx and here 6. Correct, no? Then when I compare these two, you can very clearly see here, our qx function should be this thing. Right? Okay. Therefore, qx function is equal to x cube plus ax squared plus bx plus c. Now we can find qx substituting for a, b and c. A minus 6, B 11, C minus 6. X cube, A minus 6, B 11 and C minus 6. Right? This is our Qx. Now this Qx only, people, ask and show x minus 1, x minus 2 and x minus 3 are linear factors of Qx. Right? Okay. Now when I put x equals 1, that already we have done. Right? Anyway, Q1 we can write. Q1 going to be 1 cube minus 6 into 1 squared. 11 into 1 minus 6, no? Then here we get 1 minus 6. 11 minus 6. You know, 1, 11, 12. Minus 6 minus 6 minus 12, 0. Right. According to factor theorem, people, Q1 0 means, therefore, x minus 1 is a factor of what? Qx. Right. Similarly, put x equals 2 and x equals 3. X equals 2 and x equals 3. When you put x equals 2, Q2, we get 2 to 3, 6 into 2 squared is 4, 11 into 2 minus 6. Here we get 8, 24, 2 into 2 minus 6. Correct, no? Here 30, here minus 30, 0. Q2 0. Therefore, x minus 2 is a factor of Qx. Right, put x equals 3, Q3. Right. to the power 3 minus 6 into 3 squared, 11 into 3 minus 6. Here 27, 54, 33 minus 6. 27, 33, 60 minus 54 minus 6 minus 60. Also 0, no? Then x minus 3 is a factor of qx. Therefore, x minus 3 is a factor of qx. Right. That's okay. Right. Now people are asking what is next. Also find the quotient and remainder when qx is divided by x squared plus 1. Right. Now we can go to the log division method. No? Log division. Qx is divided by qx is divided by x squared plus 1. Right, qx function is this, no? Right. X cube minus 6x squared, 11x minus 6 is divided by x squared plus 1, no? Right, okay. All right, this x cube we divide by x squared. We get x. We write that we are here. By that x, we multiply this and write below. X and x, x square, x cube, x and x squared, x cube, plus x. Now subtract this from this. X cube, 0, minus 6x squared. 11x minus x is 10x minus 6, right? We get. Now this minus 6x squared, we divide by this x squared. Then we get minus 6. This and this, minus 6x squared and minus 6. Here's the difference. This minus this 0, 10x. 6 minus 6 also 0. Then we get the final answer. Right, so then you can write quotient x minus 6 remainder. Remainder is 10x, right? Okay. Next one, question number 5. Right, question number 5, next part. Right, question number 5 says, 5 part 1. It says, using a suitable substitution, solve this equation. Right, 5 part 1. To the power 2x plus 2 minus to the power x plus 4 is equal to the power x plus 4. We can write this as how? To the power 2x into to the power 2, no? Correct, no? Then this bases are equal. When they are multiplied, the exponents we have to add. By this we get this, no? To the power x plus 4. This one you can write to the power x into to the power 4, like this. Right, and here people, this to the power 2x I can write to the power x whole to the power 2, like this. Huh? This one we can write this way, no? This x and 2 when we multiply, we get this. 2 squared is 4. Therefore I write where? Here. Minus to the power x and 4 a to the power 4 means 16 into 2 to the power x. Now we take one substitution here, let t equals 2 to the power x. For every 2 to the power x we put t. Then we get here t squared 40 squared minus t plus 4 16 t. Right, now take this to this left hand side, 40 squared minus 17 t plus 4 equals 0. Right, now you can factorize this into two factors like this. Two factors come in as 40 minus 1 and t minus 4. Then we can find two answers for t. By the first factor we get t equals 1 upon 4, right? Second answer give t4. But we need to find x, right? What is this t? T is 2 to the power x. Put that here. 4. I can write this way 2 squared. Bring this to numerator. 2 to the power minus 2. Then x going to be minus 2. First answer is x is minus 2. Secondly, this t 2 to the power x equals 4 means 2 to the power 2, x is 2. The two answers are these two. Right now, the two answers are these two. Right. Right, second part. Solve this way. Question number 5, part 2. Asking to solve log x to the base 2 plus log x to the base 3 is equal to 1 over L into plus 1 over Ln 3. Here people remember Ln 2 mean given logarithm of 2 to the base e. Right. You will learn this e, exponential e. In the exponential function, the constant is that e. Its value is approximately 2.71 up to 2 decimal places. That such value is e. Okay. Ln we write like that. Then, to get this answer, I am going to write this log by using the change of base formula, applying the base 10, log x to the base 10 divided by log 2 to the base 10, like this. This one, log x to the base 10, log 3 to the base 10. Right. The right hand side also, people, this Ln 2 I can write this way. Ln means log base e, no? I write it as log 10 to log e 10, like this. And this 1 over log, we can write applying base 10, here 3, here e. Okay. Then in the next line, you can take this log term to this numerator, this to this numerator. Then those two are equal at the numerator. You can take that out from the numerator. In the left hand side, this also in the left hand side common. Then I can take that out. Log x to the base 10 inside bracket 1 over log 2 10 1 over log 3 10. This way we have equals taking this to numerator and this to numerator, when you take it out, we get here log e 10 right hand side 1 over log 2 10 plus 1 over log 3 10, like this. Okay. The left and right, these two you can cancel down here. This way you can cancel down. Then we get a log x10 is equal to log e10. Right. Now we can remove log from both sides. You can't cancel down this log. That is actually wrong to say. Cancellation log from both sides is not applicable method to get this x. And then we can say here removing x, removing log, not x, removing log from both sides. Once you remove this log base 10 from both sides, left hand side we get x, right hand side we have e, then x equals e. Right? Okay, x equals e. At part 3 in it, no? Next. Solve the following simultaneous equations for x and y. Third part. 16 to the power y is equal to 2 to the power 2 times 2x minus 18. Next one, log 3 x plus y 1 plus log 3 x minus y. Right, then this 16 we can write, people, 2 to the power 4 and its power y. Here 2 to the power 2 times 2x minus 18. This and this we can multiply. 2 to the power 4y is equal to the power 2 times 2x minus 18. Bases are equal, no? The exponents we can equate. Then we get 4y is equal to 2 times 2x minus 18 divided by 2. 2y is equal to 2x minus 18. Again we can divide by 2. We get 9 here. Then we get y minus x is equal to minus 9. Number 1. This one, right, I can take this equation log x plus y to the base 3 right. Next one, here this 1 I can write like this, log 3 to the base 3. This is 1, and log 3 x minus y. When we have two log terms this way as sum, you can write multiply this and this and write in under the base 3 of log. This way, log 3, this and this we can multiply 3 times x minus y. Right? And here we have log base 3x plus y. Now here also we can remove, right, log from both sides. Then we get x plus y is equal to 3 times x minus y. Okay. Simplifying this, we get what, people? Here we get 3x minus 3y. Here we get x plus y. Right. Take this x to this side. 3x minus x is 2x is to this side. 4y, no? Cancel down this way. X equals 2y. Equation number 2. Now we can take the values of x and y by solving 1 and 2. Right. Solve 1 and 2. Here, people, x is 2y, no? We put 2y here. Right? By 1 and 2, we get y minus x. X is 2y. Is equal to minus 9. Minus y equals minus 9. Y equals 9. Y equals 9. If y equals 9, x is 18. By 2, put 9 where here? 18. X equals 18. X equals 18. Right? That's how we take that answer. Okay. Next one, number 6. Right. On the same diagram sketch the graph of y equals mod x plus 3 minus 1 and y equals 2 times mod x minus 3. Right. Mod x plus 3 minus 1, number 6. Minus 1. And second function, y equals 2 times mod x minus 3. This, huh? Okay, we know when we define the mod x plus 3, the mod value changes at minus 3, no? Then x plus 3 mod will be equal to, on the right hand side of minus 3, x plus 3, left of minus 3, minus x minus 3, right? The first thing is x less than minus 3, this function y is equal to, on the left of minus 3, mod x plus 3 takes this, no? Then this place we put minus x minus 3 and minus 1. And we get minus x minus 4. Right? Secondly, x greater than or equal to minus 3. Right? This takes y equals x plus 3, mod x plus 3 is equal to x plus 3 minus 1. Y equals x plus 2. This way. Right now? Then we will first draw that sketch on the OXY plane like this. This is the y axis. Right? And this is x axis. Changes at x equals minus 3. Suppose here minus 3. Right. When we draw this line, Definitely this x equals minus 3 we have to put here and find one point. X equals minus 3, put minus 3 here, minus 1, minus 3, plus 3 minus 4 is minus 1. Right? So this is the turning point of the graph. X equals minus 3, it is minus 1. Suppose minus 1 here. Right? This is that point. Right. Okay, that graph here has the intercept minus 4. Then minus 4 we can take 1, 2, 3, 4. Somewhere here, 4, minus 4, right? Right. Then this and this point we have to join, that we draw by a dotted line, because the graph we must draw on the left of minus 3. To draw the straight line we need 2 points. As one point put in x equals minus 3 we found one point, y minus 1. Other point, as our other point we took the intercept. So the line we can draw by joining these two and producing to both ends. But we need of that line only the part on the left of minus 3. So that is why draw in this way by dotted line. The rest part we draw this way, right, by producing it like this. Right. Then this has the equation y equals minus 6 minus 4. The other one also, people, when I put x equals minus 3, for that also x equals minus 3, when you put here minus 3 plus 2 is minus 1. That also starts from this point. But for that one, the second point we can take its intercept 2. So 2, we can take 1, 2 somewhere here. Then that passes through this way. Right, no? This way we get that line. Right, its equation is y equals x plus 2. Right, second graph is this. We'll draw that too. Right, mod x minus 3, no? It changes at 3. Mod x minus 3. On the right of this, x minus 3. Left of this, minus x plus 3. Right. X less than 3. What do you get? Y equals 2 times. Less than 3, mod x minus 3 is equal to minus x plus 3, no? In 2 times, minus 6 plus 3. Y equals minus 2x plus 6. Right, number 2. X greater than or equal to 3. What do you get? Y equals, on the right of 3, mod x minus 3 is x minus 3, no? Right. So then when you multiply by 2, we get 2x minus 6. 2x minus 6. Right. Then here also, to get 1 point, we have to definitely put this x equals 3 here. Then 1 point we get x equals 3, y 0. The same come in here when you put x equals 3, y 0. All right. At 3 here. 3, 0. Right. Okay, then we get minus 2x plus 6. Intercept is plus 6. Somewhere here it cuts, no? This and this we have to join. The line passes this way. Right, this way, right? 6. Okay, and the other one people 2x minus 6, right? Then other line should be like this, right? I draw it like this, huh? They must intersect people at 2 points, but in my diagram, this line of course should intersect with this, right? So then I take it so that this way to cut it somewhere like this by erasing this, huh? Because they must cut each other. Because here gradient is 1. This one, the equation 2x minus 6. Gradient is 2. Gradient 2 means more inclined with the x-axis. Gradient 1 is less inclined. Then this line less inclined with the x-axis. This is more inclined. So therefore they must meet somewhere, right? Okay, so I will draw them so that they meet. Right. Right, this way, right. This way we take now, right. Right, now we can take here, this is the line with the equation y equals x plus 2, no? Right. Now the two equations of these two parts, this part is on the left of 3 minus 2x plus 6, no? What is the equation of this? Y equals 2x minus 6. Right. We got that, yeah? Right. Right. So let us take this point A and this as B. Right. Now let us find the x coordinates of A and B. This point x coordinate and this point x coordinate. Right. To find them, we have to solve this equation and this equation to find this x coordinate. We have to solve this equation and this equation to find the x coordinate here. Okay. Right. Right. So then point A and point B we can find. Point A, we can find point A. Right, point A we can write y x plus 2 and right this sorry y x plus 2 and this y minus 2x plus 6, y minus 2x plus 6 we solve together. Right, equate the right hand side. X plus 2 is equal to minus 2x plus 6. Bring this side, 3x equals 4. X equals 4 by 3. Right, this is the x axis. X equals 4 by 3. Secondly, point B. Point B we can take by solving this and this. Y equals 2x minus 6 and y equals 6 plus 2. 2x minus 6 is equal to x plus 2. Then we get x and 8, no? Right. Therefore, this coordinate x 4 by 3, this coordinate 8. Okay. Now let's see. Next part. Right. Using the graphs, find the range of x of the inequality. Right. Now, Right, now the given inequality is mod x plus 3 minus 2 times mod x minus 3 minus 1 greater than 0 now. I take this right hand side. Mod x plus 3 minus 1 greater than 2 mod x minus 3. Okay. You can see in the diagram, this is the black graph. Right. In the diagram, this is a blue one. Ask him the black graph should be above the blue one. Black graph is above the blue one. You can see here. In between A and B only, the black one is above the blue one. Then the solution of that inequality going to be the 2x values. Between these 2x values only, black one is above the blue one. So therefore, the solution for this is what? Right? X less than 8 greater than 4 by 3. 8 and 4 by 3 we can't take because here we don't have equal sign. So therefore, by the graph, right? This happens where x less than 8 greater than 4 by 3. Right. This is the answer for the inequality. This. Right. Second, ask another one. What is that? Yes. X by 2 plus 3 mod minus mod x minus 6 greater than 1. Okay. We'll count that. Okay. Right. Mod x plus 2 mod x by 2 plus 3 minus mod x minus 6 greater than 1. Right. I take here, let t equals x by 2. It means x equals 2t, no? Using cross multiplication. Right. Here t plus 3 mod minus 2t minus 6 mod greater than 1. Here plus t plus 2. Plus 2 you can take out from the mod. Positive value we can take out from the mod. So, it's t plus 3 minus 2 times mod t minus 3 greater than 1. Take this one to this side and this to right hand side. Right. This way we get. Then you can see that inequality is nothing but the same thing this. Only thing is, in place of x, over there we have t. Right. Therefore, for this, if we get the answer of x like this, same answer for t we can write. Because instead of that x, here we have t. Right. So, I can write here t less than 8 greater than 4 by 3. But our t is what, people? X by 2. Then for the place of t we can put x by 2. Right? Now we can take the final answer thereby. Right, then final answer we can write. Therefore, 4 upon 3, right, less than what is t there? T is x by 2, no? X by 2. X by 2 and 8. Multiply this by 2. 8 by 3, x less than 16. This is how we take the answer for the next part. Question number 7. Relative to the vector origin O, the position vectors of the points A and C of the square OABC are simple A vector and simple C vector respectively. The midpoint of BC is D and E is a point on node E. E is a point on AD such that AEED 2:1. Find the Poisson vectors of the points D and E in terms of A and C vectors. Show that the points OAB are collinear and find the ratio OE is to EB. Let X be a point such that CX equals 3A vector and the lines OX and AD intersect each other at F. Find the ratio OF is to FX. Right? That is the question number 7 vector question. Right. Right. Number 7 is the square. Right. Here O A B C. O A vector simple A. Position vector here A. Or C vector simple C. Position vector of C simple C vector. Right. Next one given this way, midpoint of BC is D. Here D, midpoint of BC is D, yeah. Right. And E is a point on AD. AD is here, right? It's a point of AD such that AEED 2:1. This is 2, this is 1. Find the position vectors of the points D and E. Position vector of point D and E, right? OE is the position vector of E. OD. Right. We can write OD vector, right? OD vector we can write as OC vector plus CD vector. This way, right? OD vector, OC vector simple C. CD vector means since D is the midpoint, people this CB vector is equal to OA vector. That's a well obvious thing. Since D is midpoint, CD vector going to be A by 2, right? A by 2. Vector divided by 2. Then OD, the position vector of D is A vector plus 2C vector by 2. Next one, OE vector. OE vector we can write OA plus AE. OA plus AE. OE vector, OA vector simple A vector. AE vector you can write people as a part of this AD vector. Whole AD vector divided into 3 parts. Out of that 2 parts we have to take this AE. Then AE we can write 2/3 of AD. 2/3 of AD. And then OE vector you can write A vector plus 2/3 of AD vector we can write AB plus BD. Correct, no? AD vector here. A to D vector you can write AB plus BD. Right? AB vector is equal to people. Right? I write this one. AB vector plus BD vector. Right. Then OE vector is equal to A vector plus 2/3 A to B vector is same as O to C vector, simple C vector. B to D vector, people, you know, B C vector is minus A. D is the midpoint. Then BD is minus A by 2. Minus A vector divided by 2. Then OE vector we can write. OE vector we can write. Simple A vector plus 2/3 C vector plus and minus 2 and 2 we can cancel down, A by 3. Right. Then we can simplify this. Taking the common denominator as 3. When you simplify this, here 3A minus A 2A and here 2C, take 2 out. A plus C within bracket we get. This is OE vector. Right. Now let's ask you next. Asking, show that the points OEB are collinear. OEB are collinear. That means OEB, the 3 points lie on the same line. That's what we need to prove. Alright, first we'll find the OB vector. Now, OB vector we can write. OB vector, when I write, OB vector is this, no? When this, we join this A. Right? Right. That we can write OA plus AB. OA plus AB, right? Right. OA vector is simple A vector. A to B vector is simple C. This is the OB vector. Right? Now you can see, people, here we have A plus C. For that A plus C we can write OB. Then we can write, then OE vector is equal to 2/3 A plus C means this OB vector. Right? Now you know this vector and this vector equal. When two vectors are equal, the corresponding line segment should be parallel. This says what, people? OE parallel to OB. Right. OE line, this. OB line, this. They are parallel. They start from the single point, same point. Two line segments are parallel. They are starting from same point. That means the lines should be overlap each other. It says OEB 3 points should lie on the same line. So therefore we can write by this OEB collinear. Therefore OEB are collinear. Now also asking next one there, OEEB ratio, right? So now when these two vectors are equal, people, we can write this way. When these two vectors are equal, the left hand side modulus, right hand side modulus we can take. When two vectors are equal, sizes are also equal, no? Right. So then also we have what? By this we can write OE length is equal to 2/3 OB length. Right. Now I can write by that OE, bring this OB to the left hand side denominator like this, 2/3. Then what is asking there? OEEB ratio. This says when O to E is 2 units, from here to here, 2 units. O to B, here to here, it's 3 units. That means EB should be 1. So therefore this implies OE is to EB ratio is 2:1. 2:1. Right? OE 2 units, OB 3 units. That means OE 2 units, EB 1 unit. Correct. Next one, given this way, right. Let x be a point such that Cx 3a. Right, Cx 3a. Right, Cx, alright, 3a. Cx3a means, people, we have to produce this line 3 times the length of OA, or 3 times the length of CB, this way, right? Right. So this is the point X now, right? X is here. Right. Cx3a. Right. Now what is next? And the line OX and AD intersect at FR, right? OX will join this way, right? Right. This is the point F. Right. Cx is 3a. Cx is 3a. Right. Now asking what? Find OF Fx ratio. All right. Right. Now we count that. Right. Now I will take this way. OF Fx ratio I will assume as 1 is to lambda. Let OF, right, OF Fx ratio 1 is to lambda, and AF FD ratio 1 is to mu. OF Fx, OF Fx, if this is 1, this is lambda. AF FD ratio, AF FD ratio, if this is 1, this is mu. Right. Now we are supposed to write this way. This OF vector I am going to write in 2 ways. First we will write OX vector. OX vector you can write OC plus CX. OC plus CX. OC vector is simple C. CX vector given as 3 simple A vector. Right. Then we get OX vector. Now I can write this OF vector. OF vector. How to write, people, the OF vector? OF vector we can write as a part of OX vector. How? OX vector we divide by 1 plus lambda, and we take one part of that. Then OF vector we can write OX vector divided by 1 plus lambda. Then OF vector is equal to OX vector C plus 3A divided by 1 plus lambda. Right. Let us take this as number 1 vector. Secondly, I can write again this OF vector in another way, this way. Also OF vector we can write, that is this vector, no? OA plus AF. OA plus AF. OA vector plus AF vector. OF vector is therefore equal to simple A vector is OA. AF vector you can write, people. AF vector you can write as a part of AD. AD vector we have divided by 1 plus mu and take one part. Then we get AF, right? Then we can write AF vector AD vector divided by 1 plus mu. Right. Now OF vector is equal to A vector plus AD vector is AB plus BD. AB is C, BD is minus A by 2. So therefore we can write c minus a by 2 divided by 1 plus mu. Right? Okay, this is the second vector equation. Now we need to find that lambda, right? Now to get the lambda, what we can do is this 1 and 2 we can equate, right? So 1 is equal to 2, right? Or if I can write is say c vector divided by 1 plus lambda plus 3 divided by 1 plus lambda a equals, here people, vector a plus vector c divided by 1 plus mu, right? And this minus a by 2 I write this way, minus a vector divided by 2 times 1 plus mu, this way. Now our purpose is to find people this lambda. Then what we can do here, we can equate left and right the coefficients of a and c, right? Okay, coefficients of a when I equate people, here 3 over 1 plus lambda equals, right hand side here we have 1, another coefficient here we have what? Minus 1 over 2 times 1 plus mu, like this. Okay, right. This is the first equation, right? Equation number 3 therefore. Then secondly we will equate the coefficients of c, right? Then we get equating coefficient of c, secondly both sides 1 over 1 plus lambda, right hand side 1 over 1 plus mu. For these people you can very clearly see lambda equals mu, no? Lambda equals mu, right? Taking reciprocal, cancel down 1 and 1, then lambda equals mu. Then lambda mu equal, therefore in number 3, for this place of mu we put lambda, and simplifying you get lambda. Lambda only we need to find, okay? Okay, then we get now by number 3, right? We get this way, substitute for this mu, lambda. 3 divided by 3 divided by 1 plus lambda equals 1 minus 1 over 2 times 1 plus lambda, right? Then we'll multiply this by 1 plus lambda. 2 times 1 plus lambda will multiply, yeah? Then here we get 6. Here we get 2 times 1 plus lambda. Here we get people minus 1. Then here we get 2 lambda. Here minus 1 and 2. 2 minus 1 is 1. Once we take that one to this side, we get 5. 2 lambda. Lambda equals 5 by 2. We get lambda 5 by 2, right? Lambda equals 5 by 2. Right, now what is the question asking there? Question asking O if x ratio, right? Now we know O if x ratio we wrote as how people? 1 is to lambda, no? Lambda is 5 by 2. Multiply this by 2 we get O if x ratio is what? 2 is to 5. 2 is to 5, right? This is how we take that. Right, next question number 8. Right. Number 8, it says the least resultant of two forces is 10 newtons when the forces are perpendicular to each other. Their resultant is 50 newtons. Find the two forces. Right. Now, you know, we'll take two forces as x and y. Let the forces be x and y. Right. For two given forces, people, the least resultant is their difference. Right. So then we can write x minus y is 10, number 1. Right. When the two forces are perpendicular to each other, the resultant given as 50 newtons. Right. When the two forces perpendicular to each other, the resultant given as 50 newtons. No. Right. You know, when two forces are perpendicular, the square of the resultant going to be x squared plus y squared. Square of the resultant of that two perpendicular forces is given by sum of the squares of the two forces. X squared plus y squared should be equal to square of the resultant force 50 squared. Then we get x squared plus y squared is equal to 2500. Number 2. Now we have to solve this 1 and 2. Right. Then by this number 1, we can subject y, bring this to this side, this 10 to this side, y equals x minus 10. That y x minus 10 we put where here? Put in number 2, right? We get x squared plus y means x minus 10 perfect squared equals 2500. Right. Here we get x squared plus x squared minus 20 x, no, plus 100 minus 2500 equals 0. Taking the 2500 to left hand side. Then we get there 2x squared minus 20x here minus 2400 equals 0. Dividing by 2 we get x squared minus 10x minus 1200 equals 0. So there are factors you can take of this quadratic equation, right? X minus 40, x plus 30, right? By this bracket we get x equals 40. By this bracket we get x equals minus 30. This is, of course, we reject the force has a magnitude. In this case, we consider only the magnitude of the force, right? So then magnitude means size. Size cannot be negative. This is impossible. Right? So therefore x is 40. Then one force is 40. Right? Therefore y should be 30, no? Right. By number 1, x is 40, no? 40 minus y equals 10, y is 30. Therefore the two forces are 30 and 40. Two forces are 30 and 40. At its second part, the resultant of two forces P and Q is R. When Q is doubled, R will be doubled. When Q is reversed, again R will be doubled. Find the ratio P is to Q is to R. Right. Okay. two forces here P, here Q. So the angle between them is theta. Resultant is R. Secondly, we are given second case when force Q is doubled, that means new force is 2Q. The angle between them still is the same angle theta as before. This occasion the resultant doubled 2R. Right? Now the third case given. The third case it says when Q is reversed, that means Q acts in this direction. Q is reversed. P is still the same. Q is reversed means this direction. Then this angle going to be phi minus theta. Then we are given the resultant is again doubled 2R. Right. Now we can write three equations for these three situations. First one, R squared is equal to P squared plus Q squared plus 2PQ cos theta. Number one. For this one, 2R squared means 4R squared P squared plus 4Q squared plus this into 2 means 4PQ cos theta, number 2. That one again 4R squared equals P squared plus Q squared 2PQ cos phi minus theta. Correct, no? Cos phi minus theta means cos 180 minus theta. Cos 180 minus theta is minus cos theta. Right? So then we get minus 2PQ cos theta. Number 3. Right. By this we are supposed to find this process this way. We take 1 plus 3. 1 and 3 we add. We get 5R squared to left hand side. P squared, 2P squared. Q squared, 2Q squared. These two you can cancel down. Right, so then there we get P squared plus Q squared. Divide both sides by 2. 5R squared by 2. Right, let us take this as number 4. Secondly, we multiply third equation by 2 and add with number 2. Third equation we multiply by 2. This one we multiply by 2. That one we add with this. Then this will be minus 4PQ cos theta, no? That and this will cancel off. Here 2Q squared, 4Q squared, we get 6Q squared. 2P squared, P squared, 3P squared we get. Here 8R squared and 4R squared, we get 12R squared. Right. So we can divide this by 3. We get P squared plus 2Q squared is equal to 4R squared. This is number 5. Right. Now we can take by 5 minus 4, we can take Q. 5 minus 4 take, right? P squared minus P squared we can cancel down. 2Q squared minus Q squared is Q squared. 4R squared minus 5R squared by 2. Then we can write Q squared. How? Take the common limit as 2. 8R squared minus 5R squared is 3R squared. 3R squared by 2. Then we can write Q root 3 by root 2 into R. That is how we take Q. If you know this Q, I can find this P by number 4, right? Now by 4, right? P squared, that Q squared means this 3R squared by 2 equals 5R squared by 2. Then take this right hand side. 5R squared minus 3R squared is 2R squared by 2. This and this you can cancel down. P squared equals R squared. P equals R. Okay. Now asking people there the ratio of P is to Q is to R. P is to Q is to R, right? What is your P? P of course equal to R. What is your Q? Root 3 by 2R. Root 3 by root 2R. R is R. Then we can divide this ratio by R, no? Then we get 1 is to root 3 over root 2 is to 1. Again we multiply this ratio by root 2. Then what do we get? Root 2 is to root 3 is to root 2 going to be the P is to Q is to R. This way, right? This is how we take that answer, right? Okay. Now question number 9. Right. Question number 9 says ABCDEF is a regular hexagon of side A. AB is horizontal. Forces of magnitudes 3P, P, 4P, 2P and P act along the sides AB, BC, DC, EF and FA respectively in order of the letters. Find the magnitude and direction of the resultant force. Now two forces alpha and beta added to the system along BF and BE in the directions of order of the letters. If the system of forces is in equilibrium, find alpha and beta. Right. We'll draw that diagram. Regular hexagon. Right here. Right, this way we have the regular hexagon. Right. Here A, B, C, D, E, F. The force act in 3P, P, this way 4P and 2P here and P here. These are the forces, right? So there are 5 forces: A, B, B, C, D, C, E, F and F, A. Right. Now we'll resolve the forces horizontal rightward. We'll take the algebraic sum as x, resolving right this way. We take x, people, this exterior angle of a regular hexagon we know 60, this also 60, this also 60, this also 60, right. We get 3p, this one p cos theta, 4p cos theta, p cos theta, 4p cos theta, another p cos theta, right, here minus 2p cos theta, p cos theta minus 2p cos 60, no, not theta, right, cos 60, right, every theta should be 60. Correct, no? 3p, p cos 60, 4p cos 60, and again p cos 60, 2p cos 60, right? P cos 60 is 2p cos 60, we can cancel down with this. Then here cos 60 is half, no? 2p and 3p, it's 5p coming rightward direction. When resolve vertically upwards, y. By this force, no component upwards, because we know horizontal forces, right, don't have vertical components, okay. P sin 60 upwards, right, this p sin 60 downward, that too will cancel off. Here 4p sin 60, 2p sin 60, downward direction, 6p sin 60, right. Then we take downward direction, 6p sin 60. So downward direction we have sin 60 is root 3 by 2. Then downward direction we have 3 root 3p. Okay. Now we can find resultant force. Horizontal rightward, x is 5p, vertical downward, y. 3 root 3p. This way we have the resultant force R. Let this angle be alpha. Then we can write R is the square root of x squared plus y squared. Right? So then x squared going to be 5p perfect squared. Y squared going to be 3 root 3p perfect squared. Simplifying this, we get R is equal to 2 root 13p. And also this angle alpha we can write tan alpha is equal to y by x, no? Y divided by x. Tan alpha. Y means 3 root 3p. X is 5p. These two can cancel down. This gives us alpha equals tan inverse 3 root 3 divided by 5. This way we get alpha. Correct, no? Right. Now asking next part this way. Now two forces alpha and beta are added to the system along BF and BE, right, in the directions of order of the letters. If the system of forces is in equilibrium, find alpha and beta. Right, now people, we can think it like this. The whole 5 forces together give rightward component 5p, downward 3 root 3p. Then I am going to mark that 5p like this, 3 root 3p like this. then these two forces will represent these all 5 forces. So therefore, now I can ignore these all 5 forces. Instead of that 5 forces, now I can take these 2 components. Now we are given alone this BF, right here, BF this no. This here force given. I am going to mark this. This angle is 30, right? Other one is alone BE. This angle also 30. Then with the horizontal, right? This way a force and this way another force given, right? The 2 forces are alpha and beta. This is alpha. This force is beta. This angle 30 is also 30. Now, this system of forces we are given in equilibrium. And then asking to find alpha and beta. You know, when a system of forces is in equilibrium, people, when we resolve horizontally, algebraic sum of the component should be 0. When we resolve vertically, algebraic sum of the component should be 0. Thereby we can take 2 equations, right? Resolve in this way, what can you say, people? Phi p. This alpha and beta will give leftward components minus alpha cos 30. Cos 30 is root 3 by 2. Beta cos 60. Cos 60 is half. Beta by 2 should be equal to 0. Then take this right hand side, multiply by 2. Right? Beta plus root 3 alpha is equal to 10p. Number 1. Right, resolve vertically. When you resolve vertically, here alpha sin 30. Sin 30 is half. Alpha by 2. Beta sin 60. Sin 60 root 3 by 2. Minus 3 root 3p should be equal to 0. Then by this we can take the second equation. Multiply this by 2. Meantime take this to right hand side. No? Right. Then alpha plus root 3 beta is equal to 6 root 3p number 2. Right? By solving these 2 people, we can find this alpha and beta. Okay? Right, alpha and beta. Now we get the answers. Right. Then we can take it like this. We multiply the first equation by root 3. First equation we multiply by root 3 and subtract the second equation. Then what do you get here? Root 3 beta minus root 3 beta. We can cancel down. When you multiply this by root 3, 3 alpha minus alpha, 2 alpha. Right? Right hand side. Number 1 right hand side, when you multiply by root 3, then we get 10 root 3p minus 6 root 3p means 4 root 3p. Cancel down this and this, we get alpha 2 root 3p. Right. Then beta we can find, substitute that in 1 by number 1 we can write beta plus root 3 times alpha 2 root 3p is equal to 10p. Here we get root 3, here 6p, right? Then take that 6p to right hand side, we get 4p. Beta is 4p. This is how we take that. Right now? Okay. Right. Question number 10, the next. Find the constants P and Q such that this. Right. Your number 10 this way. Yes, 6x squared minus 3x plus 6. 2 times x minus 1 x plus 2. Px plus 2 q times x minus 1 squared. Right. 6x squared minus 3x plus 6 is equal to 2 times x minus 1 x plus 2 p times x plus 2, right, q x minus 1 perfect square. We'll put x equals 1, put x equals 1, and this will be 0, this will be 0, here we get 3p is equal to, when you put x equals 1 here, 6, 6 12, 12 minus 3 is 9, p is 3. Put x equals minus 2. When you put minus 2, this bracket 0, the entire product will be 0, this is 0, minus 2, minus 1, minus 3, minus 3 squared is 9q. When you put minus 2 here, 24, minus 2 here, 6, and 6 12. Q is 4. Right. Now we can rewrite this substituting for P and Q. Now asking to find the partial fractions, hence find the partial fractions of this. Right. Then I can write this equation again, substituting for this P and Q. Right. What do you get there? 6x squared minus 3x plus 6 is equal to 2 times x minus 1 x plus 2, p is 3, 3 times x plus 2, q is 4, 4 x minus 1 squared. Okay. Now asking to find the partial fractions of 2x squared minus x plus 2 divided by x minus 1 perfect squared x plus 2, right. Okay. Right. Okay, first of all, we'll take this way, people, we'll divide this by x minus 1 perfect squared into x plus 2, right. Then we get 6x squared minus 3x plus 6 divided by this. Is equal to, when this is divided by this, we get 2 over, right, x minus 1 x plus 2, we can cancel down, we get x minus 1 here, 3 x plus 2 x plus 2 x minus 1 squared, 4 over x plus 2. But people asking what? Asking not the partial fraction of this, the partial fractions of 2x squared minus x plus 2. We divide both sides by 2 again. Divide both sides by 2. Both sides by 3, not 2. When you divide by 3, here this is 2x squared minus x, 2. Divide this by and this by 3. Then we get the required partial fractions. 2 x squared minus x plus 2 divided by x minus 1 perfect squared x plus 2. Here we get 2/3 x minus 1. When you divide this by 3, we get 1 over x minus 1 squared plus 4 over 3 times x plus 2. This way we can take the partial fraction of that. Right. This is how we take the partial fraction of that part. Okay. Right. Question number 11, the last question. The position vectors of points A and B relative to vector origin O, 5i and this. Right. Right here O, 5i here. Right. This point is A. B here we have. B has the position vector I plus root 3j. This is the x-axis, along that unit vector is I. Y-axis, along that unit vector is j. Right. Then we have OA and OB like this. The two vectors. Right. But it's asking the point C is such that C equals A plus B. C equals A plus B means, people, this is your A, this is your B. C equals A plus B means C should be the fourth vertex of this parallelogram with this and this as the adjacent sides. Right. So then we can construct this as a parallelogram. This point should be the C. Right. Its coordinate position vector, if I take as C, then this OC vector only we need to find. Vector C is equal to A plus B. Vector C is equal to, right, 5A plus vector B is I plus root 3j. Then vector C is equal to 6I plus root 3j. This is the vector C. Right. People, you can very clearly understand position vector of C, 6I plus root 3j mean the coordinates of the point C going to be x coordinate 6, y coordinate root 3. Right. 6 here, root 3 here, y coordinate. Right. What is asking? Find mod C, modulus of C. Right. Modulus of vector C mean, people, that OC length. Right. You know how to find the modulus of a vector which involve I and j. How take I coefficient squared plus mod C going to be the square root of I coefficient squared 6 squared, j coefficient squared root 3 squared. Right. Then mod C going to be root 39. Okay. Right. That we found. Now people asking what is next. Find the area of the parallelogram OACB. You know this OACB parallelogram, its area you can very clearly see there. OACB parallelogram area going to be 2 times OAC area. Right? 2 times OAC area. OACB area is equal to 2 times OAC area. Right? Right. But you know OAC area mean it is a triangle. Area of a triangle half base into perpendicular height. People, perpendicular height going to be this, no, the y coordinate of the point C. It's root 3. So therefore we can write half base is OA. O to A length is 5 units. Perpendicular height, people, root 3. Then we get 5 root 3 square units as the area of the OACB parallelogram.